Welcome to our project. It's about temperature measurement with the thermocouple. This is for EUT 3451 instruments and transducers. It's by Douglas Bodnar and Juby Mathew.
The purpose of this project was to increase our knowledge of thermocouples as temperature sensors, their circuits, and how they're utilized in industry today. We're going to do this by employing the AD8495 IC chip as a pre-signal conditioner. This is going to amplify a very low thermocouple output signal to a more applicable signal that we're able to easily read. We're also going to use our knowledge of gain and offset to design a circuit so that we can calibrate it to 0 to 200 degrees C with outputs of 0 to 5 volts. That way we can utilize the full range of our Arduino input. We're also going to implement the design on PSpice to verify results and identify component values such as voltages and resistances. We will then execute the final design on a breadboard with thermocouple outputs connected to the signal conditioner, and then finally to a data acquisition system so that we may save and evaluate our data. The first part of any design process is to recognize the problem at hand. Once we have done that, we each individually conducted research to gain an understanding of how these components work and how we can put them together to work in a circuit together. We are going to use calculations and software to predict results so that we can more efficiently construct our circuit. Once our circuit is put together, we will gather and analyze the data to verify we have a fully functioning circuit and have accomplished our goals.
So we're going to be using the AD8495 IC chip, and it converts thermocouple readings from the microvolt range to the millivolt range with a positive offset of 1.25 volts. Based on the given equation, we can calculate the temperature being the voltage out minus 1.25 divided by 5 millivolts. And then with the calculation of the 8495, we determined that at 0 degrees, the voltage should be 1.25, and at 200 degrees C, the voltage should be 2.25. We then calculated the gain set point for our second stage of our signal conditioning, and we found that to be 5. And then plugging that back in, we determined the offset to be minus 6.25 volts. So a little details on this. We implemented our range, one at 0 degrees, so 1.25 volts will give us an output of 2.2 millivolts, which is negligible, and we compare that to 0. On our next design, for our 200 degrees C, the voltage at 2.25 volts, we get a reading of roughly 5 volts, so 4.998. We claim that to be 5.
So here you can see an overall setup of our circuit. We actually utilize 3 power supplies. Is an Arduino that was one of our power supplies and our data acquisition device, a multimeter to verify values, and various circuit components to create our circuit. Here you can see our multimeter reading the output. When our thermocouple is submerged at 0 degrees C, we have 2.4 millivolts, which is essentially 0. We took multiple readings at different temperatures to verify our data was not only accurate, but was linear throughout our entire span. Here you can see roughly 70 degrees C was equivalent to 1.85 volts. Throughout this process, we gained a good foundation. That way we can continue and build our knowledge.
We were also exposed to teamwork on many facets. We Zoom called, we had to come up with new ways. We spent time together working, designing, and implementing our whole circuit.
Troubleshooting was a major factor in this project. We saw some different setups that we have not got to experience before, using multiple power supplies and seeing how they work together to make different components work as a single circuit was extremely beneficial.
With our outcomes that we achieved, we were able to guide others to their own successes.
Thank you.
Thank you.